Well, I should hope you've done your jumping jacks and some push-ups, and as such, you are ready to proceed. So let's get down to business. Well, if we look at number 6, they give us two equations, x squared plus rx plus m, which is equal to 0, and x squared plus mx plus r, which is also equal to 0. Now, about these two equations, they say to us they have real and equal roots. Now, this is the most important part. The roots are equal. Now, what are the conditions for the roots to be equal? Well, that's if delta is equal to 0. Now, this is the question for us, which is worth 6 marks. They say determine the values of r and m if r is positive and m is positive. In other words, if you get a value of r which is equal to 0, you have to cancel it out because r must strictly be greater than 0. Are we fine with that? Of course we are. So let's go ahead and destroy this without showing any signs of mercy. Well, so we need to consider the first equation, right? So we say for x squared plus rx plus m, which is equal to 0. Then we need to find the delta for this one, right? And of course, we know that delta is b squared minus 4ac. Now the question is, why do we begin by talking about delta? Well, it's because they told us that these two equations have real and equal roots. So we are taking advantage of that fact. Okay, fine. So the value of b here is going to be r. So we have r squared minus 4. The value of a is 1. And the value of c is m. So this is what we say. And then we tell them that, well, for real and equal roots, what must happen? Well, delta must be equal to 0. So in other words, r squared minus 4m will be equal to 0. And we can take a pause here and consider the second equation. Well, for this second equation, which is given as x squared plus mx plus r equals 0, then once again, we need to find the value of delta, right? But we don't need to repeat the formula again. So our b in this case will be m. So we have m squared minus 4 into a, which is 1. And then we times it by c, which is our r. And once again, we tell them that for real and equal roots, delta must be equal to 0. So this means m squared minus 4r will simply be equal to 0. Okay, fine. So we can call this one the first equation and call this one the second equation. And now we can see that we have two equations, both of which contain two unknowns. So it calls for simultaneous equations. Now the question is, are we going to make m the subject of the formula, or are we going to make r? Well, you need to decide which one you want to do. So I think I'm going to make r to be the subject of the formula. Okay, fine. So let's go ahead and make r the subject. Well, from this equation, I'm just going to take this one to the right-hand side. So I find that my 4r will be equal to m squared, which means every time I see r, I actually see m squared divided by 4. And I can call this my third equation. Then I'm going to take my third equation and substitute it into my first equation. So in other words, where I see r, I'm just going to put m squared over 4. But I remember that this r is theta squared. And then I say minus 4m. And everything is equal to 0, of course. Now, squaring both of these, I find that in the numerator we have m to the 4th. And 4 squared is 16. And this is what we have. And here we can see that the LCD is going to be 16. So if we multiply throughout by 16, then what do we get? Well, 4 times 16, 16 by 2, it's 32. So by 4, it's 64. Okay. Then here we are going to take m out as the highest common factor. And so we'll be left with m cubed minus 64. And this is equal to 0. So we are supposed to have m which is equal to 0, but it can't be, right? Or we have m cubed minus 64, which is equal to 0. And if you look at this one carefully, you can see that you have the difference of 2 cubes, right? So for this one, you can choose to say, well, I'm going to factorize this as follows. Yeah, you can do that. You're allowed to do that, okay? You're allowed to do that. So you can actually say this because you know how to factorize the sum of 2 cubes or the difference of 2 cubes, but I'm not going to do that. Why am I not going to do that? Well, it's because if x cubed is equal to 8, there can only be one solution, which is x equals 2. And how do we get that solution? By finding the cube root on both sides. So that's the easiest you can do, okay? Okay, fine. So this means our m cubed will be equal to 64. And after finding the cube root on both sides, then we find that the value of m will just be equal to 4. Yes, the cube root of 64 is a solid 4. So now that we know the value of m, then we are going to substitute the value of m into the third equation so that we can get the value of r. And here we can see that, well, r will similarly be equal to 4. So this is what we are getting. And these are the values of m as well as r, for which these two equations will have real and equal roots. Over and out. Now moving on to number 7. So here they say to us, if x over y plus y over x equals 17 over 4, please calculate the two values of x over y. And this is for 5 marks. So the question is, how would you find those two values of x over y? Well, the first thing you observe is the equation that is given to you is rather complicated. And being a good mathematician, you want to simplify your equation, right? So the question is, how would you simplify your equation? Okay, let's quickly finish up erasing here, and we can talk about the how part. So this is our equation. We have x over y, which is added to y over x, and everything is set equal to 17 divided by 4. Right. Now, this is what I want you to realize. If you look at the second term, it's actually the reciprocal of the first term. Because in order for you to get y over x, that's if you say 1 over x over y, right? Yeah, so that you can say division has never divided another division. So we are going to change this division sign to multiplication. But we don't multiply by x over y. We multiply with the reciprocal of x over y, which is how we got the y over x. But this is the most important thing. We said the second term is the reciprocal of the first term, over and out. So we can stop doing this solution because we have actually done solving this thing. Now, this is how we simplify our equation. So we are going to use the k substitution method. So we are going to allow k to be x over y. So when you see x over y, you put k, but when you see the reciprocal, you put the reciprocal of k. And you say everything is equal to 17 over 4. Then here you can see that your LCD is going to be 4k. So multiplying everyone by 4k, well, here you get 4k squared. And here you get a solid 4. And everything is equal to 17k on the right-hand side. And then you want to write this equation in standard form. So you take your 17k to the left-hand side. And this is what you have. Okay, fine. So how would you solve for k in this case? Well, since we can see that we are dealing with an advanced quadratic equation, whereby the coefficient of k squared is not 1, and we can't divide throughout by the coefficient of k squared because it will result in fractions, right? So the question is, what is the easiest way out? Well, you can do it in one of two ways. You can use the quadratic formula, or you can factorize by using trial and error, right? So let's factorize using trial and error for once. So this is what we have. So we are going to list the factors of the first term and the factors of the last term, okay? Okay, fine. Now the first term can be written in one of two ways, either as 4k times 1k or as 2k times 2k. And the last term can be written either as 4 times 1 or as 2 times 2 as well. So here we are looking for a combination of factors, which if we add or subtract, will give us the middle term. So how do we find that combination? Well, if you say 4k times 4, you get 16k. And you say 1k times 1, you get k. So 16 and 1 have a possibility of giving you 17. In fact, they will give you 17k. So now, seeing what you see, then what are you going to say? Well, you say, I take my 4k and I multiply it with 2. No, not really 2, but 4, sorry. And if I do that, I'm just going to get 16k. And I take my 1k and I multiply it by 1. So when I do, I'm just going to get 1k, which is k. But then in order for these two to give me negative 17, that's if and only if both of them are negative. All right? Okay, fine. So what? So this is our first vector, and this one is our second vector. And the red negative signs are actually the signs of the vectors. So meaning this equation in vectored form is now going to be 4k minus 1 times k minus 16, and this is equal to 0. All right? Okay, fine. But why did I say k minus 16? Sorry, guys. I'm supposed to say k minus 4 because the vector is this blue part. So now using the zero vector law, we can see that 4k minus 1 is equal to 0. Then we take 1 to the other side and divide both sides by 4. So this means k will be 1 over 4, or k will be a solid 4. But the question is, what is k? Well, k is actually x over y. So this is the first value of x over y, and this is the second value of x over y. Over and out. So now it's time to look at the last question. And to be quite honest with you, it's always a joy to a learner seeing a teacher doing the last question because it means they can rest at long last. Now, this one says to us, it is given that 25 to the power 2 sine x minus 5 to the power 4 cosine x is equal to 0, where x is less or equal to 90 degrees, but greater or equal to 0. And they say, please find the value of x. And this is for 4 marks. Well, the first thing that we need to do here is to write this 25 in exponential form to base 5. So when we do that, we say, well, it's going to be 5 squared, which is further raised to 2 sine x. Then we still say minus 5 raised to the 4 cosine x, and everything is equal to 0. Then we multiply the exponents on the first term. So we get 5 to the power 4 sine x minus 5 to the 4 cosine x. But then we realize something that is terribly important, which is the fact that even though the bases are the same, the exponents are completely different. So this means we don't really have a common factor looking at these two terms. So the best we can do is to take this one to the right-hand side and solve the exponential equation. So when it gets to the right-hand side, well, this is what we are now going to have. Now the bases are the same, so we simply equate the exponents. And we divide both sides by 4. So we see that sine x is equal to cosine. And then we come back and divide both sides by cosine. Why? Well, it's because it's very difficult to solve an equation like this one. Sine x equals cosine x. How can we find a solution to that? Well, it's relatively difficult, but to make it easy, we can just divide both sides by cosine. Why? Because we understand that sine over cosine will actually give us tangent. All right? And cosine over cosine, we get a solid 1. So now we have reduced it to a single trigonometric function. So in order to find the value of x, we'll simply say it's the arctan of 1, and the arctan of 1 is undoubtedly 45 degrees. And if you look at 45 degrees, it's well between 0 degrees and 90 degrees. And guys, this should be the end of these questions. I really hope you found them useful. And there's actually a one or two things that you have learned in this video. So thank you so much for watching. Let's see you in the next video.